This section is about mortgages and loans, like loans usually for larger purchases for things like cars, because the way that those loans work is a little bit different from the loans that we had in 5C. So the loans that we had in 5C, where the interest was calculated up front, that's what you get for things like payday loans, cash advances, that sort of thing, where usually those loans aren't that big and the terms of repayment, the time frame isn't as long, right? Usually it's a year or shorter. Maybe you have ones that are like 18 months. But with a house, probably not going to be 18 months, right? It's probably going to be a lot longer than that, right? When you look at how long mortgages are, usually it's 15, 20, 25, or 30 years, right? So when you have a longer loan like that, usually they're set up a little bit differently. So what we have in this section is something called amortizing loans, which are also sometimes called installment loans. And the way that those work, so there is compound interest, like in the last section, but it's a little more complex because you have regular payments, and as the loan is being paid down, the interest is also getting compounded. But because the loan is being paid down, that's going to make the principal smaller every time. So it's not like you can just do one calculation and be done. Basically, in order to figure out just the interest by itself, you would have to do it for every single period because for every period you'd have a different principal amount. So basically what happens is that the bank would loan money to a borrower over a set amount of time. So I stuck in parentheses like a 30-year mortgage or a 20-year mortgage or a 15-year mortgage, anything like that. And then the borrower pays off the loan in regular payments, and the typical setup is to where the payments are all the same size. So that's what we're going to have. And then as the borrower pays off the loan, interest is compounded at the end of every payment period, so interest gets added to the remaining balance. Okay, so the formula that's here, and this is the thing that we're going to need. I think in the Newton notes, at first they have it solved for the principal amount, and then they redo it where it's solved for the payment amount. But the way that we're going to need it is solved for the payment amount. So I just jumped right to it. The way you derive this is actually, well, it uses a thing from Calc 2, because what you would have to use here, and in a way, I would rather not have the formula just sort of appear out of thin air. But I can tell you where it comes from. That the formula is derived from something called a geometric series, which is a thing that you would cover if you take Calc 2. It's toward the end of Calc 2. So it's sort of long to get the derivation, but that's where it comes from. So I figured it was at least worth saying, like there is a way to justify where this, how this comes about, rather than just saying poof, there's the formula. But the Newton notes use different notation for this. Like I think they use a K instead of an N and that sort of thing. I tried to keep all the notation as consistent as I could from the last section to this one. So I stuck with P for the principal amount, which would be the balance at the very beginning before any payments have been made, right? So just the principal amount of the loan. R being the annual interest rate, N being the number of compounding periods per year, T being the length of the loan written in years rather than months or anything like that. So I tried to keep those all the same. The payment amount, there wasn't really a great other letter to use, so I stuck with what was there in the notes and just used the D for that. So the lowercase d, that's going to be the payment amount per compounding period. So I guess D for like down, like you're starting to pay down the loan, right? I guess that's how we can think of what the D would stand for, if the D is going to stand for something. But what the compounding period is, usually this is a month. So this is going to be usually a month long. It wouldn't have to be. I mean, you could set it up to where you could have annual compounding periods or quarterly compounding periods and things like that. But by far, the most conventional thing, like for a mortgage or for paying off a car loan, is to make monthly payments. So that's what we're going to stick with. When I ran through the homework every single question had monthly compounding periods. So it seems like that's a good thing to stick with. All right, so how does this formula work? Well, we're going to sub in and simplify it. And I guess the biggest thing might be how you should simplify that thing in your calculator, because if you can't do a bunch of operations all in one line in your calculator, then you do have to be kind of careful. And I would probably do the denominator first in that case. I think that would end up being simpler. So I'll kind of write that out next to, I guess, where we actually get the answer. All right, so this is going to be a car payment, which works the exact same way as a mortgage payment. It's another amortizing loan. So used car for sale for $9,500, and a potential buyer's offered financing where they can pay off the car in 5 years with an annual interest rate of 8.9%. And we want to figure out how much the monthly payment is. So the monthly payment is going to be D, right? So let's see what and monthly, right? I guess that's how you would get that N is 12. Even though I guess a minute ago I said we're just going to keep N being 12 the whole time. But it does say monthly, so N would have to be 12. All right, so the amount of the loan is $9,500, so that's our principal amount. Then let's see, next thing that shows up in the wording is the T, so that's 5 years, right? That's how long it would take to pay the loan off. Annual interest rate of 8.9%. If you convert that into decimal form, it would be 0.089. And then N is 12 because it's monthly payments. Okay, so then D, if I just go ahead and sub in, I don't have a ton of room if I'm also going to write in the calculator stuff. So rather than writing out the formula, I guess if I scroll up, maybe I can get them on the screen at the same time. I think so. I think this will all fit. So P is 9,500. And then this will be times 0.089 over 12. And then will be over 1 minus, and then this will be 1 plus 0.089 over 12 raised to the power of the negation of 12 times 5. And multiplication dot. Didn't end up right where I wanted. Let me just fix that up a little. There, that's a little better. Okay. What you get, because the only thing that I think you could really simplify while putting it into your calculator or before putting it into your calculator would be the 12 times 5. So that thing that's in parentheses in the denominator, that's going to get raised to the power of negative 60. But let's see, I think the best thing is I'll just say what you get, and then over on the right, I'll write out how I would do it with a calculator. So what you get for this, at least to the nearest cent, because you're going to have to round off, and since it's money, I think that's the best, most conventional way to round off. You get $196.74 as a monthly payment. So how do you get that? Or how do you do it with a calculator? All right, so with a calculator, so if you have to go piece by piece, I would do the denominator first. So I guess what I would do first is the thing in parentheses. So 1 plus 0.089 over 12. And I guess if you really have to go one operation at a time, you would do the 0.089 over 12 first and then add 1. But whatever that is, then the next thing is I would raise that to the power of negative 60. And you don't really need the parentheses, at least if you have a TI, if you just do caret and then negative 60. And I guess make sure you use the negative sign, not the minus sign. But I think with the parentheses, that, I don't know, that makes it a little more obvious what that actually means, with just me writing it out by hand. It looks weird writing it out by hand without the parentheses, I guess. At least it looks weird to me. But then after you do that, oops, I forgot the ANS. So that's what you would type in, but the ANS, so the ANS, like the answer in the previous line, raised to the power of negative 60. There, that's really what I was shooting for. And then whatever that is, you want 1 minus the answer in 2, so then it's 1 minus previous answer. And that would give you the denominator, right? So at this point, that's what you'd have. And then for the fourth step, I guess then you'd have 9,500 times 0.089 divided by 12, and then divided by the previous answer that you would have from number 3, and that would actually do it. That would give you the 196.74. That was how I did it. And like I have a TI calculator, like a graphing calculator, where I could do all that in one shot. But if you do it all in one line, you got to be careful, especially with that denominator, to make sure you have enough sets of parentheses and things. So for me, it's just easier to do it where I just do the denominator first, and I get what that is. And once that's stored as an answer in the calculator, I go, all right, numerator divided by whatever that denominator was, that previous line, and then that's it. So that's the way that I would do it. And I guess, you don't have to follow what I do exactly, but whatever feels like it's the simplest, because honestly, once you know what your numbers are and you got them subbed in, like that's the remaining work, right? Is just knowing what to do with your calculator. Because, I mean, you can do that algebra by hand if you really want to, but with some of these exponents where you're going to get exponents of like -60 and -240 and stuff like that, I wouldn't want to. So I'm assuming nobody else wants to. So then that it really does become knowing what you have to do to get your calculator to give you the thing that you're trying to get. All right, next. Let's see. I think the next one is fairly similar, at least with the part A, because the next one's got a part A and a part B. Part A is figure out what the monthly mortgage payment is. So I guess since this one's a house instead of a car, it's going to have bigger numbers, right? That would make sense, right? Unless it's a very expensive car, that's going to be the way it goes. So Carla wants to purchase a house valued at $168,000. This sort of thing shows up. What's in the next sentence? That she has $40,000 available as a deposit. So that gets paid down initially, which means the loan is not going to be for $168,000. The loan is going to be for $128,000 because of that $40,000 deposit. So like this is a key thing here, right? And that's going to affect what P is. So what we're going to get is that P is going to be $168,000 minus $40,000, because that $40,000 is going to be paid down right away. And so the only thing that, well, only $128,000 has to be taken out as a loan for the mortgage. But yeah, like you can subtract off that initial payment, right? Like that down payment, right? That's done, right? That doesn't need to get loaned out. Let's see, the rest of it, monthly payments. All right, so right there, we know that N is 12. Right, so N is 12, and then it's a 20-year mortgage. So I guess if I'm not having commas, I'm just spacing stuff. I'll just keep doing that. So 20-year mortgage, so T is 20, and then R 0.024, right? Convert that 2.4% into decimal form. All right, so then D, I guess this time, since it's not on the page, I'll rewrite what it is. So it's P times R over N divided by 1 minus 1 plus R over N raised to the power of negative NT. And then we just have to sub everything in. All right, so if we sub everything in, then this is going to be 128,000 times 0.024 over 12. And then that's going to be over 1 minus 1 plus 0.024 over 12 raised to the power of negative 12 times 20. All right, this time 0.024 over 12, I kind of picked an interest rate so it would divide evenly. That's 0.002. So if you wanted to slightly simplify this, I guess you could. And write this, because this doesn't always work. It doesn't work in number 1, where 0.089, 12 is not going to divide that evenly. But here you could do it and say this will be 128,000 times 0.002 over 1 minus, and then if that fraction is 0.002, then the thing in parentheses must be 1.002, And this would be raised to the power of negative 240. And once again, I can never write 4s in exponents with this tablet. I don't know what that's about. There. And this ends up being 672.06. Okay. There's the monthly mortgage payment. The total interest paid, it's hard to get that directly, but we could get the total payment because we know what the payment is per period. And we can say, well, if we have that 672.06, and then that's going to be 12 times a year for 20 years, it should be that monthly payment times 240, basically. That would be our total payments. And then we can subtract the principal from that. And then that'll tell us how much the interest is. So that's the way that you would do it. So let's see, the total payments. I guess I can write this generally, where then it would be D times N times T. Right? It's the payment per period times number of compounding periods per year times number of years. Right? So that's the, if I write it out in words instead of symbols. So payment per period times the number of periods per year, and then I guess times the length of loan. So length of loan, barely fit it in. And so then this is going to be in years. Right? So that's really what we're doing. We're multiplying the payment per period by the total number of periods, right? Which is what N times T would be. Right? If it's the number per year times the number of years, right? If it's 12 times a year for 20 years, that's 240 payments. And that's what we're going to get here. So what we're going to have here, it's going to be 672.06 times 12 times 20. And if you have that rounded, what you'll get is, let's see, so it's 161,294.40. And then this is with D rounded because that 06, like that 6 cents, that's rounded off, right? Like it keeps going. Let's see, with D unrounded, so like if you just have whatever you get for D and you have it in your calculator and you just say previous answer times 12 times 20, which is actually the way that I did it. So with D should be an R, not a D. Unrounded. You get that the total payments are, and this should be, it's a little lower because you round up to the 6 cents. So it's 161,293.75. And in the grand scheme of things, is it going to matter if you round off D or don't round off D? I don't think so. The homework's tolerance will be enough to where it'll accept both. I actually ran a couple of these both ways and did it rounding and without rounding just to see if it would say one of them was wrong, and it didn't. So the homework tolerance will take care of that. And also, like in the grand scheme of things, right, if your total payments are like $161,000, and that difference between the two, it's less than $1, right? So like at that point, yeah, like does the change in the couch matter when your total payments are in 6 figures? I wouldn't think so. But the interest, and I did it off of this one, where it's unrounded. So since that's the one where I've got it figured out on this piece of paper next to me, I guess that's how I'll write it here. So the interest would be, in general, it's the total payments minus the principal. So I did it with the unrounded D, so 161,293.75 minus 128,000. So that's going to end up being 33,293.75. So there's the interest. So there isn't a direct way to get it based on the formula, but there's an indirect way, right? You can figure out the monthly payment, then you multiply that by the total number of payments. There's your total payment, and then subtract off the principal. And that excess of the total payment, that's what's there beyond the principal, that's your interest. All right. Number 3 is honestly kind of in the wrong spot. I think when I had, because I had these set up when I had all the like blueprints for the notes written out by hand, all the problems were on individual pages, and I think I just kind of got them out of order. But then it fit together so perfectly this way that when I caught it, I just thought, well, and I guess we can do it in this order, and then number 3 will just kind of be foreshadowing for what happens later. Really, 3 kind of belongs with the amortization schedule. So this is slightly out of order. It would make more sense to do 4 and 5 first, but I think that would actually make it a little more confusing the way that this is arranged now. So this really, I'll just say it goes with the amortization schedule, which is a little bit later in the notes. So like number 6 and number 7, that's what those are. Because what you have to do with 3 in order to get the balance after 1 month, basically you have to get the monthly payment and then split it, because the monthly payment will be comprised of 2 parts. There will be the part where you're paying off some of the interest, then there's part of it where you're paying down the balance, and you have to be able to split that out. It's not that crazy, but it's slightly out of chronological order. All right, so let's see what we can do here. What do we know? Well, we know how much the loan is for. So that's our P, right? The $28,000 taken out to finance buying a truck. Then the terms of the loan, we know what R is. That's 0.053. And then we know what T is, because that's 6. And then it's monthly payments, right? Presumably, if we're asked about the balance after 1 month, so N is going to be 12, right? In order for that to make any sense. So, all right, let's see what we can do. So D, if we just sub in, I'm just going to put the numbers in this time because I got to make sure I have enough space down at the bottom. But let's see, we're going to have, so it's P times R over N, so times 0.053 over 12, and then dividing by 1 minus 1 plus 0.053 over 12 raised to the power of negative 12 times 6. And what you get is 454.84. All right. So then how do we do this? Well, D is generally comprised of 2 things. So the monthly payment, so I'll just write it as D, but it's broken up into 2 things. So it's the payment toward interest plus the payment toward the principal. All right, so then basically we need to figure out what the payment toward the principal is, right? Because then if we just subtract that out, that would give us the balance after 1 month. But we have to do it indirectly because we can get the payment toward the interest, and since we know what D is, then we can solve for the payment toward the principal. And the way that we can get the payment toward the interest is that we know how much the first, we know what the interest rate should be per period. So I'm going to do this kind of up in the corner, just in a different color. So let's see. I think I can carve out about that much to do it. So I'll say interest rate. I guess it would really be per period, but here it's per month since that's what the periods are. So this is actually what R over N is. So this is 0.053 over 12. And then the interest is going to be computed on based on whatever the balance is, but for the first period, nothing's been paid down yet. So the balance is the principal amount. So that means that for the first month, so first month interest, we're going to have R over N times P. Since P is the remaining balance at this point, right? If we haven't made any payments yet. So then we're going to have 0.053 over 12 times 28,000. And what that is 123.67. All right. So that's what we're going to need, because now what we can do down here is we know what D is, that this is 454.84. And the payment toward interest, well, I mean, we'd be paying down that 123.67. And then the remainder of the 453.84 would be the payment toward the principal that would reduce the overall balance, or reduce the outstanding balance. So plus, and I guess this doesn't really have a symbol, so I'll just rewrite it as payment toward principal. And if I rewrite this a little bit, because the thing we're trying to get is the payment toward the principal, so let's say the payment toward the principal is going to be 454.84 minus 123.67, which is 331.17. So in the first period, that's how much the balance gets paid down. So then the balance after 1 month would be the principal minus the 331.17. So balance after 1 month, that's 28,000 minus 331.17. And so then that's going to be 27,668.83. There. So that is actually going to be our final answer right there. So it's a few steps to get there, right? It's based off of getting what the monthly payment would be, but then we had to split it. And this is easier to see when you have everything in table form, like in number 6 and number 7. But at least for the first period, that's the one where the interest is just based off of the principal. So, right, since nothing's been paid down, so just multiply the monthly interest rate by the principal. That'll give you the amount of interest, so you're paying that off, and then whatever else, like whatever amount is left after that's paid off, that's the amount that you're paying down the principal. And so then from there you can figure out what the outstanding balance would be at the end of the month by just subtracting that from the principal amount. All right, let's see. Then number 4 and 5 are comparing loans. So this actually won't involve splitting things up. So we have a couple loans. They're for different amounts of time. They have different interest rates. And then let's say the thing that you're concerned with is just, well, I want to be able to pay a smaller total amount of money, which would be the same thing as saying I want to pay less interest. So that's what we're trying to figure out here. So what you'd have to do here is figure out, basically you have to figure out the total payments, right? Because then you can say, well, if we get the total payments, then the one that has the bigger total payment would have to include more interest, right? Because it's principal plus interest is total payment, and the principal is going to be the same for both of these, right? The principal is $6,400 each time. So what we're going to do is we're going to get the monthly payments, multiply it out to get the total payment, and then we should be able to figure it out from there. All right, so loan A. All right, so monthly payment, we'd have $6,400 for P times R, which is 0.1 over 12. And then that'll be over 1 minus 1 plus 0.10 over 12 raised to the power of negative 12 times 3, since it's a 3-year loan. And what you get for D is 206.51. And then the total payment, so total payment, that's going to be, in this case, D times 36, right? Because it's D times 3 times 12. And what you get is, let's see, 74, 34, 36. And if you run through these and get something slightly different than I do, it's because I didn't round D. I just got it in the calculator and then multiplied out by 36 without rounding. So for this one, I guess I can kind of put that underneath and say D, not rounded. And that's actually enough, right? You could do it off the total payment. So I'll leave it there for now. We can get the interest at the end, but the total payment, I think, is enough to get you there. And then for loan B, all right, same principal, $6,400, but now we have the annual rate of 6%, so it's a 0.06 over 12. And then in the denominator, 1 minus 1 plus 0.06 over 12 raised to the power of negative 12 times 5, since this is a 5-year loan. And what you get for D is 123.73. All right, smaller initial payment, or like smaller monthly payment, but that makes sense because the loan's longer. So the total payment here, so this one's going to be D times 60, right? Because it's D times 12 times 5, since it's a 5-year loan. And what you end up with is 74.2380. So the one where you pay less interest is the one on the right, barely, right? It's by less than $11, but it's a little bit less. And if you really want to get the interest, you can. I mean, you can do it just based on the one that's got the smaller total payment, but in both cases, the interest is just the total payment minus $6,400. So you could compute it. It's not too bad, right? So here the interest would be 74, 34, 36 minus 6,400, which is 1,034.36. And then over here, the interest is going to be 74.2380 minus 6,400. So that's going to be $1,023.80. Right? So certainly that one right there is the one where there's less interest. All right. So when you compare the loans, that's probably the thing that you're looking for. Another question that comes up in the homework is finding the absolute difference. And that's what I have for number 5. So with number 5, the monthly payments are already figured out. So that's most of the work, right? Like now we just have to figure out the total payments by multiplying out. And then from there we could figure out the difference in interest. The difference in interest would actually just be the same thing as the difference between the total payments as well. So I guess I don't know if I'd call that cutting a corner, but I guess if you see that, that's one little step that you could cut out. But for loan A, so we want the total payment. And so let's see, with loan A, the monthly payment is $1,262.96. So $1,262.96, and then times 12 months times 25 years, since it's a 25-year loan. So I guess really it's $1,262.96 times 300, and what you get is $378,888, and it works out to be that exactly. Like it's that and 0 cents. That was a complete stroke of luck that I ended up with one that just terminates like that with no sense. I wasn't aiming for it. It just kind of happened. If I aimed for it, it would take forever to actually get it to work, right? Murphy's Law and all that. But then the interest would just be the difference between the total payment and the principal. So it would be the $378,888 minus $255,000. And so what you would get there is going to be $123,888. So you look at that and you go, it's kind of a lot of interest, right? That's like basically half of what the amount of the loan was. Yeah, although when loans are really long, that tends to be a thing that can happen. And loan B is going to be kind of like that as well. So for loan B, the total payment would be $1,061.39 times 12 months times 30 years. And this one does not work out perfectly to be an exact number of dollars. It's $382,140. So then the interest, so that'll be the $382,140 minus $255,000. And then what you get is $127,140. So then the absolute difference, it's the absolute value of the difference, which I guess you could look at it as just you subtract one interest from another, but you just do it in a way that you get a positive number. So you subtract the little one from the big one, right? I mean, that'll give you the absolute value if you just do that instead. So the absolute difference, you could do it with an absolute value, or you could just do it as big one minus little one. So that's, I think what I would do is just say, well, the 127 is the big one, right? That's bigger than 123. So 127,140 minus 123,888. And then that'll give you 3,212.40. All right, so I guess in theory this is an absolute value, so I'll just put the absolute value symbol in a different color. But if you do big one minus little one, that's the equivalent of taking the absolute value. All right, so that's, I think, everything except for the amortization schedule, but there's a lot that goes on in those. So that's what the rest of this section's about. This whole next page is just kind of explaining how they work. So an amortization schedule, aka an amortization table, I guess for obvious reasons, if you look down to where it is on the screen, it certainly looks like a table. And it shows the details of individual loan payments. So basically, it shows what the individual payments are, and then how each one breaks down into the amount that's paid toward interest and the amount that's paid toward the principal. Or I guess the amount paid toward the outstanding balance. right? Because it's only paid toward the principal the first time. After that, the outstanding balance is actually going to be smaller. All right, so this idea that part of each payment is used to pay down the principal balance and then part is used to pay interest, that's a thing that we kind of already had in number 3. But I guess if you skipped over number 3 and then if you're going to do it here, then it would be kind of brand new. And so the specific amounts vary. So notice how like the payments are all the same, right? Like in that example, they're all $661.95. But then the interest is not the same amount every time. The debt payment is also not the same amount every time. And notice what's happening. The interest is getting smaller. The debt payment's getting larger. That happens every single time. So like as you go through it chronologically, the interest, so this always decreases. I'm writing this backwards. So this always decreases or always goes down. And then this one always increases. And the other thing is like the increments, like how much they increase or decrease, that should be consistent from one period to another. If there are slight differences, it's just due to rounding to the nearest cent. Which actually that helps because then even if what you end up with isn't like the exact same decrease for the next period, if you're looking at interest, it should be almost that, right? It should be almost the same decrease, just maybe off by 1 or 2 cents. And same thing with the debt payment increasing. So the differences from one period to the next period to the next period to the next period, like the gaps ought to be about the same size. And the only reason they're different is just because of rounding. But then the other thing that's there, the balance at the end, so that's the remaining balance on the loan. So that's, you basically just subtract off the debt payment. And that's essentially the idea. So if you've done number 3, like if you went through that one earlier with this video, then the idea of how you break the payment up into 2 pieces isn't going to be anything new. And then even just getting the remaining balance won't be anything too crazy either. So how do you do it? All right, first thing would be getting the monthly payments or the individual payment amounts. That it's just that formula where it's D equals that big quotient. And then the way that you get the interest is that you multiply the rate per period, which realistically it's going to be the monthly rate because it's the only kind of period we've got, by whatever the remaining balance is. So for the first row, the remaining balance is the face value of the loan, right? It's the principal amount. So there, you're just going to have the monthly rate. So annual rate divided by 12, and then times the face value of the loan, the $50,000, and that'll give you $258.33. Then the way that you would get the second one is that instead of using the face value, you use what the remaining balance is. So that's the part that's different. Like that's how you get the $256.25. Because in the second row, you would base it on what the remaining balance is, right? It's like this is the balance left on the loan. We calculate the interest based on that. Since that, I guess like that little piece of it, the 403.62 has been paid down, so it's going to change the overall balance a little, right? It's going to make it decrease a little, and then once you have the interest figured out, then you can get the debt payment by subtracting. And if we go back up to where the table is, there, I can get it all on the screen at once. That's all it is to get the debt payment. So the 403.62, that's 661.95 minus 258.33. Then the one in the second row, the 405.70, that's 661.95 minus 256.25. And then to get the overall balance, or like the remaining balance at the end, that's the previous remaining balance minus the debt payment. So the new remaining balance, which is a thing called balance in the table, that far right column, it's the previous remaining balance minus whatever the debt payment is. So if I scroll back up to where we can see the table, for the first row, before that first payment is made, the remaining balance is the face value of the loan. It's $50,000. So to get the remaining balance after the first payment, it's $50,000 minus the $403.62. And that gives you the $49,596.38. Then in the second row, before the second payment is made, the remaining balance is the $49,596.38. But then if that's paid down by $405.70, then we subtract that and we get the $49,190.68. And those I just have written out at the very bottom of the page there. So the new remaining balance, it's the old remaining balance minus the debt payment. So that's how that last column works. And then let's see. So for number 6, we just have to first figure out the annual interest rate because we are actually going to need that in order to do part B anyway. If we didn't have it, we'd get stuck. So I think the way that there was a question like this in the homework, and it was just like find Z. But if you're going to find Z, you'd have to find the annual interest rate and X and Y first. So might as well just have them all kind of itemized out. All right, so the first thing is we want to figure out the annual interest rate. We can actually get that using the first line because we could figure out the principal because the balance after the first payment, there's only been one payment. So that would mean that if we took that balance that's there, the remaining balance, and added that first debt payment, that would have to give us the principal back. So then the principal or the face value of the loan would have to be 195,228.01 plus 771.99, and that adds up to $196,000. Okay, and why does that help us? Because we know how much the interest is. Right? We know the interest in that first period was $715.40, and that must have been calculated based off of the $196,000. So what we're going to have is that $715.40 is equal to R over 12 times 196,000. Right? Because in order to get that interest, the $715.40, it would be the monthly rate, which is the annual rate divided by 12, times that 196,000. And then from there we can solve for R. I guess it would be multiplying both sides by 12 and then dividing both sides by 196,000, and you'd end up with something that looked like this. So you'd have 715.40 times 12 over 196,000, and that's going to be R. So if you make a calculator simplify that, you end up with R being 0.0438 or 4.38% if you write it in percent form. Okay, well, that's a helpful thing because then we're going to actually need that in order to get X, basically. Because then we have to get X, Y, and Z, and we're going to need the annual rate to get X. All right, so then what we're going to do for X, I guess, and I'll write this in a different color, that the interest, so this is the X part, it'll be the interest rate per period times the remaining balance. Okay. So then that would mean that X is going to be, well, it would be R over N times whatever the remaining balance is. And if I go back up here, just scroll up so we can see it, when we're into that third payment period, the remaining balance at the end of the second one, or the beginning of the third one, would be $194,453.20. So that's our remaining balance. So $194,453.20. But then we know what R and N are, since R is 0.0438, right? So we can say, well, then this will be 0.0438 over 12 times 194,453.20. And then that's going to be 709.75 when you multiply that out. All right, so there's our X. And then the Y is the debt payment, which is just the difference between the overall payment, I guess, and the interest. So debt payment would be equal to the monthly payment minus the interest, right? Because each monthly payment, part of that is to pay down interest, part of that is to pay down the remaining balance, which would be the debt payment part. All right, so then that would mean that Y is going to be, let's see, so what a payment is, if I go back up, $1,487.39. Okay, so the monthly payment is $1,487.39, and the interest was $709.75. So what you get for the debt payment is $777.64. Okay. Then the last thing is the new remaining balance, which is Z. So the new remaining balance is equal to the old remaining balance minus the debt payment. All right, so then that would mean that our new remaining balance, which is Z, the old remaining balance was the $194,453.20. So $194,453.20. But then our debt payment is $777.64, so we can subtract that out. And our new remaining balance will be $193,675.56. There. All right, so basically we just went through and did that whole next row, just piece by piece. But that's what ended up happening. So we already knew what the monthly payments were. From there, we could figure out what the interest was, and then that's enough to split it into the part that would be paying down interest and the part that's paying down debt. And then to get the new remaining balance, just subtract off the amount of debt that's been paid down in that period. And that will do it. Okay, last part, number 7, it's doing the whole thing. So I figured, even though there's not a question like this in the homework, if you can do the whole thing, you can do the individual parts, right? That seems like that makes sense. So that's what number 7 is. It's just doing the whole thing, where we know how long the mortgage is, we know the face value of the loan, the principal amount, that's the $145,800, and we ought to be able to do it from there. So let's see what we got. All right, so P is $145,800. We know that T is 30, right? 30-year mortgage. We know that the annual interest rate is 0.0384, and we know that N is going to be 12. Okay. And if you look at this interest rate, because you know how we had another one, it was a similar number where it was 0.438. The reason that it's the same digits is because I was aiming for something that would be divisible by 12. So that's why. That's the real reason. So then that way we would get dollar amounts that were clean. We wouldn't have to round off. That's why. So anyway, first things first, we have to figure out what the monthly payments are. But that's what our formula does, right? So we got to go back to that and say that D, so in general, it's back here where D is P times R over N over 1 minus 1 plus R over N raised to the power of negative NT. So we're doing that again. All right, so this will be 145,800 times 0.0384 over 12 over 1 minus 1 plus 0.0384 over 12 raised to the power of negative 12 times 30, right? 30-year mortgage. All right, what you get for this, and I guess if you want to simplify, you can. 0.0384 over 12 is 0.0032. So since that's divisible by 12, I guess we could make it a little easier putting it into the calculator. So 1 minus 1.0032 raised to the power of negative 360. And if you put that into your calculator, what you get is 682.69. So that's what the monthly payments are. So 682.69 there, and then 682.69 there. Right? They would be the same. If we had all 360 of them, they would all say 682.69 in that payment column, right? Same payment for every period. All right, then I guess we got to go by rows. So we'll do the first row, then the second row. There's not really another way to do it. So row 1. All right, so the interest, that's going to be, it's R over N. I guess in general it's R over N times the remaining balance, which here is the exact same thing as the principal, right? So this will be 0.0384 over 12 times 145,800. So then that's going to be 466.56. All right. So I guess we can put that in the table. So 466.56 goes in there. And then the debt payment would be the difference between the monthly payment and then that amount of interest. So the debt payment is then going to be 682.69 minus 466.56, which is 216.13. All right, put that up in the table as well. And then if we pay down the debt by 216.13, then the new remaining balance would be 145,800 minus 216.13. And if we subtract that, we're going to get 145,583.87. All right, put that up in the table as well. So 145,583.87. Okay, second row, we kind of do the same thing, except now the remaining balance is a little bit different. So I guess that'll change the numbers. Won't change the process, but it'll change the numbers. All right, so then with row 2. All right, so then this time, when we get our interest, so it'll be, once again, R over N times the remaining balance, which I'm going to abbreviate because my hand is getting tired. And this will be 0.0384 over 12 times, well, now the remaining balance is the 145,583.87. And if you multiply that out, what you get is 465.87. All right, I guess we can put that in the table. So I scroll up to where the table is, 465.87. And something that should work as a safeguard a little bit is the amount that's paid toward interest should go down as you go through the periods, right? So that makes sense that that's a little smaller than the one that we had for the first period. And then the debt payment should be a little bigger, right? So then the debt payment, that's going to be, let's see, so it's 682.69 is our monthly payment minus 465.87, and what you get is 216.82. All right, so then that's our debt payment for the second period. So we can put that up here. So 216.82, all right, a little bit bigger than the last debt payment. And then for the remaining balance, or I guess the new remaining balance, so new remaining balance, we'll start with the old one and then subtract the 216.82. So 145,583.87 minus 216.82 will work out to be $145,367.05. So put that up on the table. So 145,367.05. And there we go. Right, so if you were going to make the amortization schedule by hand from scratch, I think we've got a template for how to do that now, right? And like I said before, you won't have to do it from scratch in the homework. Like they'll give you something where part of it's already done. Usually the monthly payment's already been figured out, and then some extra stuff will already be filled in. And then you'll just have to do things like figure out the annual interest rate, or maybe figure out like the balance in the fourth period if the first three are totally filled in. It'll be stuff like that. It won't be doing the whole thing from scratch. But I figured if we ran through one of these, and like if this one made sense where we did do the whole thing from scratch, then the individual pieces should feel easier, right? At least in theory. So hopefully that actually worked, that my thought process there was valid. But anyway, I think that covers all the stuff for mortgages and loans in 5E.